Hey, it's me, Steve. It is June 26, 2017. Time is 12:07. Temperature is about 73 degrees out. I'm going to do a little Geo-Rant, just short, because we are going this weekend for 4 or 5 days, haven't decided yet, up to Canada, because Canada's 150 this year, and then the 4th of July is like right in that time frame too. But we're going to go away we never have gone before. We are going to go up Ontario 129. And I've been wanting to do this for a while. I've just never been able to in the past, because usually we kind of stay around Wawa or Sault Ste. Marie. We know those places pretty good. But I want to check out the geology. There's a lot of Archean rocks, mostly granites, gneisses, some greenstones. Like there are in the Wawa area. But on the south end, there's also the Huronian Supergroup. And before I talk about that, I just want to give you a general sense of the geology, the bedrock geology in the Great Lakes area. Generally, as you go from south to north, the rocks generally get older. Obviously, there's exceptions to this because we have things like basins and anticlines and faults, but generally that's what happens. So if you're like where I live in Indiana, the bedrock is mostly Silurian, Devonian, kind of that. By the time you get to Lake Superior, you start getting Mesoproterozoic rocks of the Great Rift, or of the Mid-Continental Rift, sorry. And then you go north of that, you start to get your Paleoproterozoic and your Archean rocks. Now the Huronian Supergroup is cool. I really like this. It's mostly a package of metasediments. Mostly sandstones, salacious dolostones, mudstones that have been slightly metamorphosed. But at the very base, there's volcanic units. And what this package of rocks, the supergroup, represents is the first true evidence of full-blown plate tectonics, plate tectonics in full operation, kind of in a similar way as it is today. Because what this represents is a successful rift. You get volcanics at the bottom, and then you start to get what we call passive margin sediments. You start to get sandstones, you start to get shales, you start to get carbonates. And the Huronian Supergroup is Paleoproterozoic. It's began being deposited about 2.5 billion years ago, because we can date the volcanics at the base. And fortunately for us, it's also cross-cut by dikes and sills that date to about 2.2 billion years. So although the sedimentary package is extremely thick, it only represents about 300 million years of time. And this sedimentary package is huge. It's on the order of dozens of miles thick. And it has been subsequently folded, faulted, and all that stuff. But the Huronian Supergroup shows that typical passive margin development, like what we would expect to see if the Atlantic Ocean were to start closing again. The package would be very similar to what we would see off the eastern coast of America, because the Atlantic Ocean was a successful rift. It rifted, and sediments started pouring down into the ocean, and if that were to close, it would form faults and stuff like that, and other intrusions. It would become an active margin again. And something like that seems to have happened with the Huronian Supergroup. When it stopped being deposited, we don't see evidence of a continent or an island arc hitting it, although there may be one there, just deeply buried or just not recognized. But what you could have had was, as the Huronians became a passive margin, that passive margin, eventually the plate got old, sunk, and started subducting, and that would have done it too. But there's something else interesting in the Huronian Supergroup. There's at least 3 definite diamictite, metamorphosed diamictite. Diamictite's kind of like the new term for till. It's a little more complicated than that. That's not an exact terminology, but for all intents and purposes, that's what it is. So we had these pre-Cambrian tillites within the sediments of the Huronian Supergroup, and these are the oldest confirmed glacial deposits on the planet. So I'm kind of excited to go up 129 because we'll see the Huronian first, and then we'll start to get into the Archean rocks. But that's my rant, and I hope you learned something.